Hello, everyone, and welcome to Scrambled. Today, I'm joined by Henry Wu, one of the brilliant minds behind Rubicon, an innovative system that fuses artificial intelligence, tangible interaction, and adaptive learning to teach Rubik's Cubes faster and more effectively. With a 25% boost in learning outcomes, Rubicon is reimagining how we approach cubing. It's especially inspiring for people like me who often teach very young children or very old people to learn the Rubik's Cube for the first time. And I'm excited to hear more about this.
Thank you so much for inviting me, Sanjay.
Okay, sounds good. My first question is, could you briefly just summarize what Rubicon is?
Okay, so Rubicon by definition is an intelligent tutoring system that teach especially novice Rubik's Cube learners to solve the Rubik's Cube. So it incorporates four key components. So it has the model tracing. Basically, we use a camera, a webcam, a typical webcam to detect, for example, when the user is manipulating the cube, how the state of the Rubik's Cube will change. And that data is recorded in, for example, a typical PC. And then the Rubicon use algorithm to detect during this manipulation what kind of knowledge component the user has demonstrated, whether they have mastered or not. And for those the skills that Rubicon detected that the user hasn't mastered, then the Rubicon will generate specific tasks by augmented reality onto the cube they are manipulating for users to practice until they master all the key components,
Do
key
you need a
skill
specific type
components.
of cube for this technology to work?
Oh yeah, we use the 3x3 Rubik's Cube.
Or like for the 3x3, do you need like a smart cube or do you need any type of markers on
Oh,
it?
not really, just a regular cube without any sensors embedded in it.
Okay, and then there's like a camera system that looks at the
Mm.
cube and then does some sort of processing, essentially.
Yeah, yeah,
Okay.
yeah. So it's like RGB camera,
Okay, okay.
and then we use the stream of it.
Do you know how many people like it was tested on, like in terms of like the 25% boost in learning outcomes? Like how many people
Mm.
is that across?
Yeah, so we recruited 36 college students. Um, yeah, they reported themselves as novices.
Okay.
Yeah, that's the number.
Did you work with the cubing club at University of Michigan at all for the first project?
Not really,
Okay.
unfortunately, but we could like have some prior discussions.
Okay,
Right.
cool. So what actually originally inspired the idea behind Rubicon?
Um, well, for a bit of a context, at that time I was just looking for a research project,
Okay.
and then I came across this project. So by the time I think a lot of project I'm into is about augmented artificial intelligence. So how to improve machines like ability. Uh, but I think it's pretty cool of this project to focus on how to enhance learners' ability. Um, and I think Rubik's Cube is a really cool domain to me at that time. So we consider it as an initial exploration because I think Rubik's Cube is both really tangible, requires pretty dexterous finger movement, physical skills, but also pretty cognitive, require learners to, figure out and master things in their mind. So I think that's a pretty cool combination um, of both cognitive and physical aspects in the task of the Rubik's Cube. And me personally, I started to play with Rubik's Cube at a pretty young age, and then also yeah intrigued me to figure out, for example, how to model Rubik's cubes, and
Yeah.
also how to help others be able to learn better.
Yeah, I was gonna ask you about your background in cubing soon because this is like a Rubik's Cube podcast. So I'm glad you
Yeah.
brought that up. And then I was curious, do you guys have any are you guys any aware of any other people or research projects that are similar to this type of technology?
Yeah, I think one demo I've seen previously is basically I think a bunch of researchers built a robot to be
Okay.
able
Oh
to
yeah, yeah, yeah. I know.
see the Rubik's cube and be able to solve it in like point a few milliseconds.
Yeah, 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 I've seen.
That's super cool. But I guess to me it's even cooler to eventually enhance learners' abilities.
Yeah.
Um,
I think it's impactful, right? And So
Yeah.
I personally started this initiative a couple months ago called Cubes for a Cure, where I teach Rubik's Cubes for people in hospitals and older people in retirement homes. And one of the things, like one of the hardest parts about it is simply just teaching the cube in itself, right? Because it can be discouraging, especially for a 3x3 cube. It's not the easiest thing to learn right away. So
Mm.
this comes into my next question. How can people like me or like institutions like cubing, like communities, like nonprofits, maybe. How can they gain access to this technology? Is it becoming public anytime soon? Or just wanted to ask.
Oh, so as a academic research project at this current stage, we essentially just build a proof of concept to
Okay.
show that maybe the concept of combining AR rendering and also the intelligent tutoring modeling can be able to help enhance the learning, but it's not yet a product
Okay.
or a deployable system in the world.
Okay.
But we hope maybe in the future we can refine the prototype and be able to extend it to the real world
Yeah, so
users.
speaking about the future, so are you guys like currently working on expanding it? Because I read like through the paper a little bit. I noticed that it's mainly for the first layer right now. And I'm
Mm.
curious if you're trying to apply it. I know you guys did mention that it should be applicable to the rest of the cube too. So I was curious,
Yeah,
are you
yeah.
guys working on the second layer, last layer, and expanding it into a deployable product essentially?
Yeah, maybe. So after I finished this project, I left University of
Huh,
Michigan and
okay.
then so
Yeah.
I will come back soon. Maybe yeah, I will work on it again to
Cool.
be able to generalize through all the stages.
Yeah. But like right now it's just like I guess static right now or
Yeah, currently just to the first layer. But
okay.
I feel like because at each stage there are a finite set of, for example, knowledge components, and all of them can be represented in a sequence of movements. So I
Yeah.
think the architectural recon theoretically can be applicable to all the stages. And I think also applies to like other types of Rubik's Cube, for example, 2x2 or
Oh
I don't know,
yeah.
4x4.
Yeah. It might even be more useful for maybe like 4x4 or like 5x5, right? Because those ones can be
Mm-mm.
harder to understand in the beginnings.
Yeah, maybe.
But I wanted to ask also, did you guys ever reach out to any like cubing like companies or like manufacturers about this technology? Because I know there's a lot of research and development going on behind like creating cubes,
Yeah.
and especially with like GAN, which I'm sure you've heard of.
Mm-mm.
They have their own smart cube. So I'm just curious if you guys have ever reached out about like them like joining you maybe on some sort of research project where you guys can create this product and deploy it, perhaps. So yeah.
Mm-mm. Yeah, the quick answer is we haven't, but
Okay.
I think that would be pretty cool
Yeah.
because actually just at a pretty high level, I think academic research in general, I feel like most of the research just stop at a pretty preliminary stage, but it'll
Okay.
be really great for all these projects to kind of uh, really be able to deploy it and be applied to the real world. So
Yeah.
yeah, I also appreciate the opportunity to because you started a lot of great initiatives and
Yeah. Yeah.
hopefully
Thank you.
it's really inspiring and I want to take those as motivation to
Yeah.
push maybe Rubicon yeah in the future
Yeah. Yeah.
maybe.
No, because I'm gonna be honest with you, like cubing is growing a lot. So I'm a speed cuber
Mm.
myself. I take about 6 to 7 seconds to solve a three by
Yeah.
three. So I've been doing it for a it's, there's a it's back on the desk, but that was a trick, magician here. But what I'm trying to say is so I've been cubing for a long time, and this year during the World Championships, like live, there were 10,000 people watching, like just live, not even like there will
Oh.
be even more people watching in behind, and there were hundreds of competitors at Worlds, and there's more money being involved. The cubes are becoming more developed, and so I've been going to competitions, right? And the last competition
Mm.
I won over I think around like $80 to $100 just worth of Rubik's cubes for just winning the competition, right? So there's more funding and stuff, and I think Rubicon could be something extremely useful for people who are trying to get into this growing hobby.
Mm. Mm.
And it's really becoming more and more than a hobby, especially like you can see with my initiatives. I'm trying to expand it to be more than just a puzzle, which is really the whole point of this podcast, to explain how it's more than just a puzzle. So, so
Yeah.
my next question is, this is kind of backtracking a little bit about creating the system. But was there any
Mm,
single like aha moment, like when you were creating this Rubicon in general?
mm, mm.
Yeah.
Um, Let me see. I think Rubicon is a pretty long pipeline.
Okay.
So
Yeah.
when developing it, I think there are like issues arise, like mostly the technical issues
Yeah.
that we had to solve. For example, initially we had to figure out how to track the Rubik's Cube state pretty
Yeah.
well. So um, I guess for the audience, if you look at a paper, eventually the implementation involve the Aruco markers, which are those kind of QR codes that we attach to each facets of the cube. But initially, we're just trying to track the regular cube with like six different colors. But it's pretty hard to detect the state really accurately in different lighting conditions.
Yeah.
Um,
Lighting. Yeah.
so that's kind of a workaround. Um, yeah, I think there's a lot of aha moments in the evaluation stage. So we did, as I said, 36 participants, you study with 36 participants, and there are a lot of really good feedback from the participant on potentially how to improve the systems.
Yeah.
Um, yeah,
That's good. Would you say that was one of the biggest challenges when developing, like at least what you have right now?
I think that's definitely one of the part that we spend a lot of time on.
Yeah.
I think I won't say the big, probably the biggest challenge would be figure out how to model the knowledge component and how to
Oh,
represent
yeah.
kind of a build a cognitive model of the Rubik's cube because I think that's the like base, yeah, the
Yeah.
core of the system.
So what's like the hardest part in continuing this project to encompass like the entire cube, I guess. Like let's say the second layer or like the
Mm,
third layer too, which I mean I can kind of like feel where it is, but I want like you to explain like maybe what
yeah,
would be
yeah.
some barriers or like constraints, I guess.
Okay, yeah,
Understanding. Yeah.
yeah. So to be able to build cognitive models, we had to build a prior task model. Basically, what kind of skills we had to explicitly list out what kind of knowledge component that is involved in each stages. So be able to extend, maybe we had to also go through that process of defining what kind of skills they are. But I think the good news is, online, there's a lot of online tutorials and like free um, like websites of documenting pretty well of what kind of cases they might be of solving the Rubik's cube. So we could figure out a really scalable way to convert them to the like the coding lab at a coding level. What kind of code we should write, and yeah, I think because we have built a overall architecture, and I think if we have figured out the how to encode all the knowledge component across the stages, then it should be pretty straightforward to do the rest.
Yeah. So have you guys ever used like a speed cuber's knowledge per se in like helping create like maybe some of this cognitive knowledge in terms of like
Yeah.
how the solutions are being like developed or stuff like that. So yeah.
Yeah, yeah. So actually, that's a really good point because I think the scope of our project actually doesn't focus on speed cubing. So I think there's a
Okay.
huge difference from my perspective between speed cubing and regular cube. Because I think in for example for me, not a speed cuber, what I do to solve the Rubik's cube is kind of I observe it first, and then in my mind I picture what kind of maybe manipulation I should perform. But I think it's pretty different in speed cubing because I think everything is almost instantaneous. You had to do a lot of really high frequency of decision making of what kind of algorithm you should apply, and you had to probably master a lot more algorithms. Um,
There's I will
so I'm
say
not
there's
sure.
like
Yeah,
for each like position, like if I'm in a particular state, I'll have like three or four different algorithms to apply, but I'll be applying them
yeah,
based on like different factors like edge orientation, the time it
yeah,
would
yeah,
take, the finger tricks or rotation. But yeah, yeah, you can keep going. Yeah.
yeah. I think if you do speed cubing on our system, probably you're gonna break it because
Oh,
our system
yeah.
detect the cube at a
Well,
there is a threshold of the technique. Yeah.
Right. Yeah. So the reason I brought it up is not necessarily I do understand that it can be difficult to like incorporate like a speed cubing component because obviously there's
Uh,
a lot of like there's a high level of processing when it comes to actually creating like an optimal like finger tricks. There's lots of parameters to consider,
yeah.
right? But the reason I bring it up is because like as a speed cuber myself, like it can I sometimes like see the cube in terms of like I've spent so much time with it that I almost have like a you know what I mean? Like a natural
Mm.
instinct for understanding like
Yeah.
why
Yeah.
pieces are moving the way they are. Like or do you know what commutators are by any chance?
Sorry, I'm not really
Oh, that's
sure
okay.
about
But
that.
basically, it's like algorithms that just swap two pieces using buffers. Like
Oh,
it's
okay.
something that like
Gotcha.
a knowledge that I've developed over the years. So I was just curious in case you guys were trying to like apply any like speed cubers knowledge, not necessarily for the speed, but maybe like
Mm.
understanding like the optimal like moves or like just optimizing like the cognitive aspect of the
Yeah. Yeah. We mainly just focus on the beginners levels algorithms. Um, but actually, a question from me, I just learned from you is that you probably develop some, behaviors that is not maybe documented in typical tutorials, right? You had a, you have some like intuitions of, for
yeah.
example, in specific cases where you're gonna like swap different blocks. Is
Yeah.
that,
Intuition. Yeah, that's a
yeah,
big
that's
one.
really fascinating to me.
Yeah, yeah, yeah. Yeah, and so that's why I bring it up because especially
Mm,
like when I'm teaching, I think
yeah,
there's a big difference between like me teaching a cube and like someone who's just learned how to solve a cube teaching a cube. Because for me, like I can adjust to maybe understanding which algorithm would be the easiest for them to understand, or I can break it down very easily because I've spent so much time that my intuition is so
yeah,
natural so that I can create a metaphor. So I'll actually use a specific example here. Let me just get my
mm,
Rubik's cube, all right? It's just right here.
yeah, yeah.
Yeah.
Sounds good.
So this is the cube right here. But
Yeah,
whenever I'm explaining like putting like a pair like this down here, like you know like the moves are like you move it to the side like that, right?
yeah, yeah, yeah. That's
The
what we
way I
do.
like to explain it to kids especially is I like to explain that it's an elevator and then you move it to the side so that you're like waiting for the elevator to come up and then you let the elevator
Mm-mm.
come to the second floor and then you board the elevator and then you take it takes you down to the ground floor. So stuff like that are just things I've developed over years of teaching speed cubing, not even necessarily just
Mm,
doing speed cubing. So that's why I was just interested in um asking if there was any like speed cubing like knowledge behind the scenes that would make it perhaps easier for improving to the second and third layers for this for or continuing
mm.
on for the project. So yeah.
Yeah, I think so. Yeah, I think for the Rubicon, I think the core principle of it is to enable as many efficient practices in terms of uh, targeting a skill that hasn't been previously demonstrated as possible. Um, so we try to optimize the learning path of the learner, but we didn't. I think that's a really interesting direction actually, because I
Yeah.
feel like Rubik's Cube at a representation so the representation we teach to the learner is essentially the manipulation, but there could be other ways of perceiving, for example, the elevator example. Um, that's really good for memorization. Also really fun to learn.
Yeah.
Maybe in the future work we'll try to explore some of the.
Yeah. Yeah, so on that note, I think we've covered what Rubicon is and we've discussed maybe some future goals for it. And I'm really excited to see where it goes maybe in the next couple of years. Maybe in the next couple of years this interview will have like 1 million views and it'll be the most famous thing in the world for teaching people solving Rubik's cubes. Hopefully.
Yeah,
But
thank you.
thank you for taking the time and speaking with me today. It was really nice talking to you and getting to know you and your background with cubing and how it led to this amazing project. So,
Yeah, likewise. Thank you,
yeah.
Sanjay.
So if you guys like this interview, be sure to subscribe, leave a comment on who I should interview next, and share it with a fellow cuber. Thank you for listening.